So let's see the constituents around the CPU, sorry, and how the CPU interacts with them. So the first thing I'll draw is the CPU itself. So I'll draw the CPU and the connectors to the motherboard, and those connectors are wires where some information might come in, and this information is encoded with zeros and ones. So it might be that this is an input, and the zeros and the ones really are abstracted from voltage that is present or not. So maybe there is some voltage here, there's some voltage there, and so on. Okay, so that's the first component. Now there are two main components that interact with the CPU via the motherboard. The first component is, that I haven't talked about yet, is a clock. So the clock serves to regulate the CPU. So it will give impulses, electrical impulses, very often to the CPU. And very often means billions of times per second, millions and billions of times per second. So that's the first component around the CPU. It will regulate it. The next component is the memory. And as we've seen, there's many different types of memory. So I'll abstract that away. I'll just say it might be registers or it might be RAM. In general, that's how it works. So RAM means random access memory. I didn't mention that before. Okay, so, and this RAM or these registers contain data. And this data is always zeros and ones as usual, but it can be of different types. So depending on the convention, it can encode different things. So if you remember, it could be an integer, it could be an instruction. So let's say we have one instruction. It could be an integer, could be yes, another instruction, maybe yet another instruction afterwards for the CPU. And then it could be, let's say, an address, a memory address, and yet another instruction. Something like that. So you have to remember that those are all zeros and ones, those are all zeros and ones, those are all zeros and ones, and they really have different meaning each time depending on the convention that is used. Okay, so how does this cycle work? Well, there are two important parts of the CPU. There's the arithmetic processing unit inside. So the arithmetic processing unit does the type of operations you would expect, or you would expect from a CPU. So it does arithmetic operations. And then there's another component, which is the control unit. And the control unit is basically taking care of which instruction to execute when. Okay, so here is an example of something that could happen. Well, we have an integer here, and this integer is written into those pins. And it's written because there is an instruction here that will say that this integer should be loaded, let's say, in part A. And this set of connectors here refers to part A. Okay, and then there is another integer here that is encoded and has to be loaded in part B. That's the instruction. So that has to do with the control unit. The control will look at this integer, the instruction, the integer, the instruction, and will progress in each of those and execute the instruction associated. So each time it reads in an integer, loads it, reads in another integer, loads it. And then the next instruction might be perform a sum. Now, sum means that sum here refers to a specific instruction in the instruction set of the CPU. So what the arithmetic unit this time will do is that it will take the input on A and the input on B, and then by convention output something on C. So by doing binary operations on the input of A and B, it will decide on a sequence of zeros and ones that correspond to those two inputs. And let's say output this on C. Okay, the next instruction here would refer to a specific address in the memory, and the next instruction is would be a save from C to that address. So this information here that is now stored here will be taken and saved somewhere else in the memory. Maybe just the next instruction may be much lower. So that's the general way the processor will work. And if you look a little bit carefully, what happens is that there are instructions, or there's stuff here, data here, if you want, data that always has to go through the CPU to get some action performed, and is returned more data that is inserted back with the data. And this cycle here is repeated again and again, as I said, and it's regulated by the clock. So the clock regulates how often this cycle happens. Some data is taken maybe once, twice, several times, pulled into the CPU, some action is performed, and is sent back. Okay, and some of the data that is pulled are integers, but it can be instructions, can be addresses, can be things like that as well. Okay, so it's really important to remember that there's this data that is sitting somewhere in the computer, and then actions are performed on this data. So you will see this again and again. So this is the volume model. The data is stored in memory, and action on the data are performed by the CPU. And it's a fetch, decode, execute cycle because the data is taken, so it's fetched, it's decoded, and it's executed, and it's repeated again and again. So if you look, there are two important characteristics. The first one is the frequency. How often does the clock beat? And it could be in the millions or billions. And then there is the word size. So when I said an integer, I meant a precise number of bits. Okay, so there's a certain number of bits that is transported at a time, not just one. And the number is really the word size. So usually you have a power of 2. In my drawing, I had 8 bits, which is often called a byte. Okay, so this is the fundamental model of how computation happens at the level of the CPU. And we will see that the programming languages help us abstract away from this basic computation model to do much more complicated stuff very easily.